Hello everyone, welcome to today's lecture. In this lecture, we are going to start with the shift micro operations. So let's start. Here, shift micro operations are used to shift the content of the register to the left or the right. Suppose our register has the 8 bits. So if I want to shift the bits of the register from left hand side or the right hand side, so at that time the operations or the micro operation used is the shift micro operation. So in short, we can say that we are moving the content in the direction of left or right. This functionality is mostly used for a serial data transfer, means when the data is a serial type. So at that time we are using these types of micro operations. During a shift left operation, the serial input transfer a bit into a rightmost position, and during the shift right operation, the serial input transfer the bits into the leftmost position. It means in the shift left operation we are shifting the content towards the left direction, and in the right shift operation we are shifting the content of the register toward the right direction. So there are mainly three types of shift operations, which are logical shift operation, arithmetic shift operation, and circular or rotate shift operations. So let's start with the first, which is a logical shift. Logical shift is also divided into the two categories, which is a logical left shift and logical right shift. So during a shift left operation, the serial input transfers a bit into the rightmost position. So it transfers 0 through the serial input. So we'll understand this by using the example, but before we'll understand the symbolic notation of this micro operations. So here SHL is used for logical shift left and SHR is used for logical shift right. So suppose we are doing a shift left operation on the content of register R. So at that time we can write it like R1 then arrow, and SHL it represents the left shift operation and register R1. So the meaning of this notation is on the content of register R1 we are performing the shift left operation. The second is R1 arrow SHR R1. It means we are performing shift right operation on the content of register R1. So this is the symbolic representation. Now let's understand how actually it shifted the bits in the register with the example. So when shifting the left or the leftmost digit in the binary representation of number, so that is also called the most significant bit, is lost and a 0 is inserted to the rightmost end. So how it is possible? Suppose we have a binary number here as shown in this figure 01010. So this is one binary number and I want to perform a shift left operation on it. So first thing is we'll add 0 at right end. Then we'll move the content of the register from right to left. We are shifting the bits. So first we'll add 0. This is a compulsory. Okay. Then the content of register. So this is a right hand side. This is a left hand side. So we have to move this content onto the left hand side. So how it can be possible? We'll add 0 and then we'll shift this bit by 1 on the left hand side. So here we'll put 0, then this content, so here 1, then 0 and 1. Here is a 1 2 3 4 5. So this is a 5-bit number. So after the shift operation this number is a 5-bit, but you can see that this 0 bit is discarded. Since all the bits are shifted one place to the left, this bit will be lost. So here we are losing these bits. Yes. So this is the output of this shift operation. This is same as 00101. Yes. So here we are losing this MSB bit. So that is the disadvantage of the left shift bit, that if we are performing left shift on the content of register, then we'll lose the MSB bit. Same as when we perform the right shift operation. So at that time we'll start with the left end, then we'll move the content one bit towards the right direction. So the number becomes 0 0 1 0 1. Okay, so this is the final output 0 0 1 0 1, and here we'll lose the LSB bit. So since all the bits are shifted one place to the right, this bit will be lost because this is a 5-bit number. So we'll get the 5-bit number and the LSB bit will be discarded. So that is also the disadvantage of right shift operation. So I hope now you are clear that how we can perform the left and right shift. Let's understand both with this example. So the binary number is 10 11 00 11. This is a LSB bit, this is a MSB bit. Now if we want to perform left shift, so at that time we'll add the 0 at the right hand side. So here we'll put the 0, and then the content of the register will be shifted by 1 bit towards the left direction. So here this is 1, so this is shifted by 1 bit, this one is also shifted by 1 bit, and so on. So here you can see that the MSB bit has a value 1, but this is not in our final output, so this bit is discarded from the register. Same as in the right logical shift operation, we'll add 0 at the left hand side, and then we'll move all the content of the register towards the right direction. So as shown in this figure, you can see that here this is the LSB bit, and this LSB bit is discarded from the register. So that is the main disadvantages of logical shift operation. So to overcome this, the next shift operation is that this is a circular or the rotate shift. So in the logical micro operations, the bit shifted out of the register is lost. In this shift operation, the MSB bit of the register are virtually connected to the LSB bit of the same register. So here the MSB bit of register is connected to the LSB bit. So in case of shift operation, the data does not get lost. Instead of, the data moves in the circular fashion. So we'll understand this with one example, but before that we'll understand the symbolic notations. So this circulates or rotates the bits of register around the two ends without any loss of data or the content. So in this, the serial output of the shift register is connected to its serial input. So the circular or the rotate shift operation is also divided into the two categories, which is a left and right shift. So circular left shift is denoted with the CIL symbol, and circular right shift is denoted with the CIR symbol. So here we can write it like that: R1 arrow, then CIL, and then R1. It means that we are performing circular left operation on the content of the register R1. Next is CIR R1. So it means we are performing circular right operation on the content of register R1. So this is an example of circular left shift. As I said that the MSB bit is connected to the LSB bit. So this is a circular left operation. So in the circular left operation, the first MSB bit is connected to the LSB bit. So the MSB bit here is a 0. So we'll write 0 here. Okay. Now in the left shift, the data of the register is moves towards the left direction. Okay, so after that we have to perform same that we are performing on the shift left operation, logical shift left operation. So here the first bit is 1, that is shift left by 1 bit. So here 1, then 1, then 1, then 0, then 1, then 0 and 0. So here you can see that we are not losing any bits in our logical shift left or right operation. We are losing our MSB bit, or we are losing our LSB bit. So here in the shift left operation you can see that we are not losing any bits because we are transferring this MSB bit to the LSB bit. So this is a circular process. Now this is a left operation. If I want to perform the circular right operation on it, okay, so how it can be possible? So for the circular right operation, we'll transfer the LSB bit to the MSB bit. So here the LSB bit is 1. In the circular right operation, the LSB bit is connected to the MSB bit. So here first it become 1. So our MSB bit for the circular right operation is 1. Now as per our logical shift right operation, the data of the register is transferred towards the right direction. So we'll start with this. So we'll write 0 here, then we'll write 0, then we'll write 0, then 1, then 0, then 1, then 1. Okay, so the content of the register after performing the circular right operation is become 1, 0, 0, 0, 1, 0, 1, 1, 1. Okay, so this is the bits after performing the circular right shift operation. So this is how the circular or the rotate shift operation works. Now the next is here not the arithmetic logic shift unit, but it is a arithmetic shift operation. So this shift assigned a binary number to the left or right. An arithmetic shift left multiplies a given signed binary number by 2 and shift left divides the number by 2. Arithmetic shift operation is also divided into the two parts, which is arithmetic left shift operation and the arithmetic right shift operation. So in the shift left operation, it multiplies a signed binary number by 2, while in the shift right operations it divides by 2. So the arithmetic shift micro operation leaves the sign bit unchanged because the sign number remains same when it is multiplied or divided by 2. And the symbolic representation for the shift left operation is ASHL and for the right is ASHR. So we can write it like R1 arrow ASHL R1 for the left arithmetic operation, and for the right arithmetic shift operation it is written like R1 then arrow ASHR and R1. Here we are using one word is sign bit. Sign bit means if number is positive then the first sign bit is 0, and if number is negative then the MSB bit is 1. Yes, we can identify any binary number based on this sign bit. Suppose 1, 0, 0 and 1. This is a binary number. So by looking at this number we can say that this number is negative. Why? The first MSB bit is 1. So based on this sign bit we can identify that number is positive or the negative. So here arithmetic shift micro operation leaves the sign bit unchanged because the sign number remains same when it multiplies or divides by 2. Yes, suppose we are multiply 30 in 3 into 2. So at that time 3 is a positive number. So the multiplication of 3 into 2 is also a positive number, is equals to 6. If we divide minus 4 by 2, so it generates the output minus 2. So the sign of that number doesn't change. So that is why in the arithmetic shift operation we are not changing the MSB bit. Yes, so here in this arithmetic left operation, this is the same as the logical shift left operation. Here we are adding 0 and then we are changing the content towards we are shifting the content towards the left hand side. Here the first two bits is same 0, 0. So at that time there is no problem if this bit is discarded here, because we are adding this 0 here. The first bit is discarded but the second bit is 0. So based on this we can identify the number is positive. If first two number is same 1, 1. So at that time also we are discarding this first number, and based on this second number we can identify that number is negative or the positive. But what happened when the number is like 0, 1 or the 1, 0? Here the number is 0, 0, but if the number is 0 and 1, at that time if we discard this number then the sign of the number will be changed. Here the original number is 0, 1, start with the 0, so the number is a positive, but after the shifting operation this digit is discarded, this bit is discarded and the first MSB bit become 1, so the number become negative. So at that time we have to remain MSB bit unchanged. So if number is like 1, 0, 0 and 1, and on that if you want to perform the arithmetic operation, at that time we are not changing the MSB bit, we will put MSB as it is, and then we'll start transferring data towards the right or the left. So here the number is 0 0, and now this bit is discarded. Okay, so this is how the arithmetic logic operation is performed on the data of the register. Here we have read that the arithmetic shift left multiplies a signed binary number by 2. Okay, so here this is a given binary number and the decimal of this binary number is 23. Okay, now we are performing the arithmetic left shift operation. It means the generated output is the multiplication of this number by 2. So it generates a 46. So the multiplication of 23 into 2 is 46. So if you convert this binary number into the decimal, so at that time the number is 46. So this is true. In the register, if you are performing the arithmetic left shift operation, then it is multiplication by 2 of this given binary number. And if we perform the arithmetic right operation, so at that time it is a division of 2. So if we perform the arithmetic right shift on this same number, so the generated output is 46 divided by 2 means 23. So it generates the binary of 23. So that is all about the shift operation. That in the shift operation there are mainly 3 types of shift operation: logical, arithmetic and circular. So these are the 3 operations, and by using this we can shift the content of the register towards the left or right. So that's it. Thank you so much for watching this video.